Is my screen visible?
Yes, ma'am.
Okay.
Yes, ma'am.
Today I'm going to tell you about the OR gate using NAND gate. So I hope all of you are familiar with the OR gate function. It is actually, if I mean to say, that is that is 0 0. If it is 0 0, then it will be 0. Okay. So AB stands for the two switches. Correct. The state of two switches. If both the switches are on the off condition, then the output will be on the off condition. Correct. So if one switch off, another one switch is on, then the output will be on. This is also the same situation. The first switch is on the on condition, the second switch is on the off condition. So obviously the output also will be in the on condition. And obviously, if both the switches are on the off on condition, so of course the output also will be on the on condition only. Correct. So this is the state. So A stands for the first switch, B stands for the second switch, and output stands for the condition of the LED. So if first switch is on the off condition, second switch is also on the off condition, output obviously off condition. If any one of those two switches will be on the on condition, output will be in the on condition. Same things, I mean to say, if both the switches are on the on condition, output of course will be in the on condition. Got my point? Next of all, next of all, that is a factor how to remember these things. Just remember, in case of the AND gate, only the last one is 1, rest of the part is 0. In case of the OR gate, only the first one is the 0, rest of the part are the, I mean to say, in case of the output column are in the 1. Got my point? So what you have to remember, this is the OR gate symbol. You have to remember it. Keep in mind very well. You have to remember it. And this is one type of, you can say the practical application of the OR gate using NAND gate. If either or situation, this can be done using the XOR gate also, but this is one form of practical application. Okay. So what is our target? We are going to implement OR gate using NAND gate. So this is the thing you have to. So just remember it. If you have to implement the OR gate using NAND gate, you remember this circuit. Not for practical, for the theoretical part also, it is very what is the things you have to remember there. You need to have the 3 NAND gate to implement one OR gate. That number, how many NAND gates are required to implement one OR gate? It's a very common question. Okay, you have to remember these things. There will be 3 NAND gate to implement one OR gate. Got my point? So this is a simple theory related to the OR gate or logic made using the NAND gate. So if either or condition, in case of the XOR gate, only the either or condition can be implemented. In case of the OR gate, both the things, or condition, even the either condition, both the things can be implemented. Okay, not this one. So I hope, I would like to suggest it. Take the screenshot of this one so that when I will be explaining the circuit, it will be easier for you to understand. And put A, I mean to say, this is the A, and this is the B. Okay, it can be interchangeable. No, not necessary it should be the A, it cannot be the A, like that. It is interchangeable. Okay. So what you have to do for implementation of the circuit, first you need to have the component. This is the circuit already made. I am explaining it now. It was made in the last year. So what is there? I'm explaining it. This is another one switch. If you want, you can use this light switch also. Just for explaining this switch operation, I have taken it. So what is this? This is the quad NAND gate IC. You can find out from here. This is the power supply. This is the resistance. This is the resistance. This is the LED. This is another one switch. It's called the root. DIP switch SPST into 4. What the benefit of using this switch? In case of the previous switches, whatever we have used, that is the slide switch, means to implement two connection, you need to have the two switches, and you need to do the six connection at all. So there are means it will be little bit clumsy when you are going to make a complicated circuit. But in case of this DIP switch, you there are four switches in one switch. Can you see this? This is one switch, one switch, one switch, one switch. Means one DIP switch, there are total four inbuilt switches, correct? So the space requirement is less. If you are going to use the DIP switch, then you will get total four switch inside it. You don't require to have the six connection like this. For suppose you have the requirement of the four switches, if you are going to use a slide switch, then you require to do total 12 connection, correct? So there will be lots of wear requirement, there will be space requirement, that will be very much uh, messy. But in case of this switch, there if you want to use the this type of switch, so their wear requirement is also less, and the space requirement is also less, and the connection is also very much easy. Okay, to make you understandable, I have used this previous year made circuit, so that the things will be easily understandable. So whatever be the switch, the this portion is same to everything. So first you have to collect the 74AC00, correct? So if you can remember in the last class, last to last class, I already have told you how to implement the circuit using 74AC00. There are total four NAND gate included in this one IC. So you can notice it here: input 1A, 1B, output 1, one set of NAND gate, 2A, 2B, output 2, second set of NAND gate. This is the ground, already have grounded. Next is this input 3A, 3B, and the output 3. This is the third set of NAND gate. This is the 4A, 4B, output 4, the fourth set of NAND gate, and this is the power, correct? So this already you are familiar with. And this is the power supply. That's all I have told you. And maybe I told you, did I tell you this? Power supply is something that is going to give you the power, I mean to say voltage into current. In case of the battery, you don't have this much of option. In case of the power supply, more advanced version of the battery, you can say. Okay, so what do you have to do? First of all, you need to connect the negative pin to this negative side indicated line, the positive pin to the positive side indicated line, and connect both the part of this breadboard like this way. Okay. So this is same in the previous classes. If I can remember, the power supply was in this side, and I have connected the black color indicated line to this portion and red color indicated line to this portion, and we have connected this portion. This is another one, you can say another one type of the designing. Okay. Next, what you have to do? Go back to this portion. You need to have this input 1, input A, and input B, this 2. So for that reason, we need to have two switches. These are the indicator of the two switches, nothing else. So what you have to do? In this case, I have collected this DIP switch from here. So as you can notice here, this is one switch, this is one switch, one switch, one switch. So this is the on. Here you need to give the power supply. Did you understand what I have to require to told you? So first of all, you need to connect this DIP switch here only. Okay, means you cannot connect it here, here, or here. You need to connect it in this portion like this IC only. Correct. Next, where the on this later is indicated, from here only you need to connect the uh, plus sign indicated line, correct, like this way. Now from here you need to get the output or need to get the connection to this IC. So next of all, what you have to do, the first NAND gate input need to be shorted first, or you can say first two input of the NAND gate need to be connected together, and that connected one need to be connected to the switch like this. First of all, you need to connect input. In my case, I have used the input 1A and 1B. First, I have shorted it here using a wire. Next, what I have done, so you need to connect these shorted things to this input. Okay, like this way. Similarly, you need to connect to A to B like this design, and next you have to connect it to this switch like this way. Okay. Next, what you have to do, both the output of this previous pin need to be connected to this third one like this way. So these two already shorted connected to this pin, these two already shorted connected to this pin, and this is the output 1A and this is the output 2. These two actually connected to 3A and 3B like this way. Got my point? And this is the output 3 that is connected to LED. Okay. Is that connection clear to everybody?
Ma'am, can you explain it again?
Okay. First of all, what you have to do, just a second. First of all, you need to connect one breadboard. I'm doing it. The one. Collect DIP switch. Collect power supply. Okay. First of all, you need to connect this positive pin to the positive side of the breadboard like this way. Change the color. Connect the negative pin to the negative side of the breadboard. Okay. Connect it. Okay. 74S00 quad NAND gate connected here. Anywhere. Means like this, anywhere you can connect it. Sorry. Connect the DIP switch also. Oh, anywhere. Okay. Not here. Anywhere like this. Next. Connect this pin. Go back to this position. What do we require to have? We require to first have this part. Means you need to have these two line. So for that reason, first of all, connect the pulse. Just a second. Yes. Okay. And this connection of this to switch. I mean to say switch is something like this. You need to have two connection. First one need to be connected to the power supply. This is a positive part of the power supply. That we have done here. Okay. Next, what do you have to do? Better first connect the ground and power supply of this IC. Okay. Next, now you have these two pin, but where to connect? You need to first short or the you need to connect this input A to both the pin of the NAND gate. Correct. So there are two options. Either you can just short this two and connect it to the input, or you can just connect it to both the input. Better first short it. So input 1A, 1B. First I have shorted it using a where. Change the color to something else. Let it be blue. So next, what you have to do? This is shorted. The input A need to be connected to here. Input A means, in my case, I have considered this one to the input way. So I just connected it here. Got it? Next is what? We have another one NAND gate. That input also shorted. So let it be done first. So 2A, 2B. Okay. So you need to connect it to here. Got it? We done both this one. So this part done. So next what we have to do? This NAND gate output need to be connected to another one NAND gate input. Same things will be happening for the second one also. This is output 1, this is output 2. So we need to get another one set of NAND gate. We can use 4A 4B, we can use 3A 3B as per your choice. So 4B, this is the 4A, this is the output that also can be taken, or you can choose this set of input also. Let's take it this 4A 4B combination. 4A 4B. This is the output. So it can be more beautification. Output. For output, what do we have? The resistance. Correct. So okay. Okay, better do it like this way. Okay, and cathode need to be grounded. I am trying to. Okay, is that clear?
Yes, ma'am.
Why it is bursting? Find out that there is a mistake. That's why I have asked you. In the last class also, someone maybe someone thinks it's not working or it's getting burst. That's why I'm telling you. Find out that how to take it, because the fault finding is also one important factor. Output 4, because your this thing is getting burst, so of course there is a problem. This device broke because of current through pin 3y is 11, while maximum is the current consumption is more. So where the problem is actually, that we need to find out. That's why actually I have taken this circuit to make you understand, otherwise I could make you understand there only. Acha, let's start from the beginning. So here it is minus sign, this is plus sign. First check from where the connection actually you have done properly or not, and in the proper place of the breadboard you have made it connected or not. That is the first things you have to check. Okay, so output, this is the things, this is the things. So this place is okay, correct? So next, chai, so kharab. This one, this is a place where we have connected the switch. Is this the same things we have connected? If I just ignore this, then also the situation is worst. Okay, so where is the problem? Acha, my mouse is not working properly. That's why I cannot connect it the same place. It need to be connected here only, where the red. Okay, I'm trying to do it, changing the mouse and connect it. So just give me a second. I am opening the previous one also to make you understand. Next of all, for making you understand, so that time will not be get wasted. So just a second. Huh? I cannot connect it in the same place. Mouse is not working properly. I'm just explaining it here. Then I'm going to there. Okay. First of all, you need to check where the connection is properly made or not. Okay, this ground pin and this power supply pin need to be connected in proper place. This is the things. Output 4 means the terminal 1 should be connected to the anode, and this is the cathode pin need to be grounded. And this is a factor, this is the input 1a, this is the input 1B. This is shorted, okay, and from here only the switch connection need to be connected. Same things will be happened here only. Input 2A 2B need to be shorted first, that we have done, and here only you have need to connect it this. Okay, I am opening the previous one to make you understand, because this switch need to be connected in the proper place. That somehow I cannot do. It is just placing here and there, okay, due to maybe mouse problem. And I hope you made it, you understand it. Just you need to connect it in the proper place. Just give me a second, I'm opening the previous one that already made. Acha, the previous one, the problem was in the switch only. Means the switch was not placed properly. When the first things cannot be connected here, the mouse is. Okay. So the circuit is same, just the orientation of the component is in the different place. Whatever I have told in the previous case also, that is also can be followed. Nothing is new, just power supply can is here, it can be here only, just the new things. The switch, as you may notice, these two switches are there as on condition. One is off, another one on. Both the switches are on the off condition, then the LED is off, and when both the switches are on the on condition, this is the on condition. That is the situation. Rest of the circuit are same, just there is a problem in this placing, switch placing. So, did you understand the OR gate implementation? Is that clear to everybody?
Yes, ma'am.
Yes, ma'am.
Okay, you start practicing this one. Raki ma'am is taking your attendance. You start practicing this one, and I am on the meeting also. Whenever you will be find any difficulties, you just let me know. Okay. If you have any query, let me ask. No problem, and you start doing it by yourself. Wherever you will be stuck, just let me know. And Raki ma'am is taking your attendance. অ্যাটেন্ডেন্সটা নিয়ে নাও, ওরা করতে থাকুক, তারপর যেখানে যেখানে আটকাবে আমাকে জিজ্ঞেস করে নেবে।